In this video, we're going to talk about three other uh, features in Simio. Specifically, we're going to talk about rate tables to model non-stationary arrival processes. And we'll also talk about um, arrival tables to model a specific arrival process. And also, we will talk about work schedules to change the number of resources over time. So let's start by the first topic, non-stationary arrival process. So in this context, we're going to assume that the restaurant, our Subway restaurant, serves roughly about 576 customers per day, which will give me an average hourly arrival rate of 32 that we already have in our model. And we're going to assume that our restaurant operates for 18 hours every day from 7 a.m. to 1 a.m. So the restaurant serves breakfast, lunch, and dinner and is open for 18 hours. So when you really think about the arrival process into a restaurant, what we really expect to see is a function, a continuous function, and I'm talking about the function of the arrival rate. So we expect the arrival rate to be changing with time. So we have a peak during breakfast, we have lunch rush, and we have dinner rush, and then the demand or the arrivals go down until the store closes. So, without getting into the theoretical details of how we model non-stationary arrival processes and how we identify non-stationarity in our arrival process, suffice to say that what we typically do in simulation is approximate our continuous function with a step function uh, that we can actually implement in our simulation model. So as you can see, we approximate our arrival rate using this step function that I have plotted here. So I am using 1 hour intervals, and I'm assuming that during the first hour interval I have about 23 arrivals per hour and so on. So as you can see, I can see the peak during breakfast time, and I can see the peak during lunchtime, and then the arrival rates go down, and then it goes up again during dinner rush, and so on. So if you would like to know more about how we identify non-stationary arrival processes and why they are important and how they can change our decision, I have another video module on my YouTube channel. It's called Historia, a tool for identifying non-stationary arrival processes, which is based on a tool that we have developed as part of a research project to identify and model non-stationary arrival processes. So let's go to Simio and see how we can model this arrival process in Simio. And specifically, we're going to talk about a rate table that we can use to model such arrival processes. So in order to implement our rate table, what I'm going to do is go to Data, and then on the left menu, I'm going to click on Rate Tables. And now here I can create a new rate table, and I can go ahead and define or specify my arrival process or hourly arrival rates in my rate table. So let me actually go ahead and set the properties of my rate table. So I'm going to have intervals of size 1 hour. Remember, we're going to use 1 hour time intervals in our step function. And I'm going to have 18 operating hours. So my time span will be 18 hours. So the next thing we need to do is specifying our arrival rates for our operating hours. So here is my step function. So as you can see, we have from 7 a.m. to 8 a.m. we have an arrival rate of 23 customers per hour. From 8 to 9 we have we're going to use an arrival rate of 39 customers per hour in our step function, and so on. So let me actually try and see if I can put these side by side. Here we go. So I'm going to just specify my arrival rate. So 23 for the first hour. We have 39, 23 again, 13, 39. We get to 71 arrivals per hour during lunch rush, and then it goes down again. It's 58, 29, 16, 19, and then we're getting close to dinner rush, so it starts to peak or increase again. 55, 50, 58, 35, 19, 19, and then late at night we're going to have a slow arrival process. So now we have completed our arrival table, so let me maximize Simio. So now that we have our table, we can go back to our facility view and tell our source object to use our arrival table, to use our rate table, sorry, to generate our arrival process. So what I'm going to do is to change my arrival mode, this time from inter-arrival time that we previously had. So remember, we were using an inter-arrival time arrival mode with an average rate or hourly rate of 32 customers per hour. But this time, since we're going to use the time varying arrival rate table, I'm just going to change my arrival mode, and I immediately get this error message that says you haven't specified the name of the table yet. So I'm going to specify the name of my table, which is my rate table 1. So now my source object will use the arrival rates that I have specified in my rate table to generate my entities. So before I run the model to see if we have actually implemented the time varying arrival process correctly, I would like to add another component to the model, which is a dynamic plot, an animation feature that allows me to see how the state of the system changes over a run. So I'm going to go to the animation ribbon and then select a status plot, and then I'm going to drag to get the size that I would like for my status plot. And let me go ahead and set the properties. I'm going to change the text scale to 1, and we're going to have 18 operating hours. So let me expand this a little bit. There we go. So the value that we're going to plot is the instantaneous number in system. So I'm going to have number in system for my y-axis, and I have time over the horizontal axis. So the next thing we need to do is put the expression for our status plot, and the expression will be basically the sum of the number in systems for my 4 customer types. So I'm going to have hot dot population dot number in system plus cold dot population dot number in system plus drink customers dot population dot number in system plus my cookies dot population dot number in system. And remember that we're not going to use the average or maximum or minimum because we're interested in the instantaneous number in system. So we're going to say okay. So now the expression we have is the sum of the number in system for our four um, customer types. So before I run the model, I would like to go to my run configurations, and so I already have set the starting time. I'm going to set the ending time for now to 1 a.m. So I start at 7 a.m. 1 a.m. the next day is the ending time. And now I just hit run and my model starts to run. And as you can see, I'm plotting the instantaneous number in system as the model is running. So we expect to see an increase in the average in the instantaneous number in system during lunch rush because our servers cannot simply um, keep up with the arrivals because we have faster arrivals than our service rates. And also, we will see a peak, but not as high as the lunch rush peak during the dinner rush. And then the, the arrival process or the number in system both go down. And finally, the model will end at 1 a.m. But when you look at this model, as you can see, there is a small problem with this configuration that I have here right now, and that's when that is when my run ends at exactly 1 a.m. or 18 hours. I still have one customer that arrived before 1 a.m. but is not processed. So that's not what we see in the real world. So what we see in the real world is that they close the doors at 1 a.m. and then they process all of the entities that are currently in the system. So in order to implement this, I'm going to stop my model and first set my ending type for my run to unspecified because I'm not sure exactly when the last customer will be processed, when the last customer will leave the system after 1 a.m. So it's going to be an unspecified ending type. But instead, I'm going to tell my source that I would like to generate or create entities only for 18 hours. So I'm going to go to the stopping conditions property category, and I'm going to set the maximum time to 18 hours. So now my source will stop creating entities at 1 a.m., just like what we want, but my run doesn't end until all of the entities that are in the system at 1 a.m. actually leave the system. So we expect to see an ending time for my run that is slightly more than 18 hours. So let's run the model again and see what happens. And so again, we're going to see the slight peak during breakfast time, and then we're able to keep up with the arrivals very well. And then we have the lunch rush, where our system actually fails. And you can see I have a long queue for my bread. We fail to keep up with the arrivals. And then it goes down in the afternoon, and then we have again, as you can see, faster arrivals than our service times during the dinner rush. So we're getting close to the ending time of 1 a.m. And so what we expect to see is again a run length of slightly greater than 18 hours, and that's exactly what happened. So my model ran for 18.09 hours. So basically it stopped at 1:05 a.m. So that's when the last customer left the system. So the next thing that we're going to do in this video is to add a work schedule for our servers so that we increase the number of resources or the number of workers we have during the peak hours so that we reduce the number in system during those hours. So for example, during the lunch rush and dinner rush, let's say we would like to have 2 workers for some of the servers that are slower than the other ones that make our system not able to keep up with their rivals. So in order to implement this logic, we will use a Simio feature called um, work schedules. And let's see how we define work schedules. Before we do this, I would like to show you our step uh, function that we use to model our arrival, our non-stationary arrival process. And keep in mind that since our slowest servers are basically the bread and veggie stations with the processing rates of both 40 per hour. I'm just going to increase the number of servers at these two stations during the hours where I have an arrival of greater than 40. So basically, uh, I have an arrival of 71 per hour from 12 to 1, and 1 to 2 I have an arrival of 58. So I'm going to increase the number of workers at bread and veggies to 2 from 12 to 2 p.m. And also I'm going to have 2 workers at these two stations from 6 to 8 p.m. So let's go back to our model and implement this logic. So what I'm going to do now is to stop the model and go to data, and this time I will go to schedules. And now you can see that we have our default work schedule and day pattern. I'm going to go to my day pattern here, and I'm going to make it basically specify the number of resources at different operating hours. So I'm going to start at 7 a.m. and I'm going to have one worker from 7 to 12 p.m. And then from 12 to 2, for 2 hours, I'm going to have 2 workers from 2 p.m. to 6 p.m. I'm going to have again 1 worker from 6 p.m. to 8 p.m. I'm going to have 2 workers, and then from 8 p.m. to I'm going to do 2 a.m. here, since we already saw that we're going to have some entities that will be um, processed after 1 a.m. But as you can see, I will get an error when I try to do this, and it's because I need to use basically um, a 24-hour period to specify my work schedule. So I'm going to do 8 p.m. to midnight to 12 a.m. with 1, and then I'm going to have another one from 12 a.m. to 2 a.m. With a value of 1. So that's how I'm going to specify my work schedule here. So now I can go back to my facility view, and I'm going to select my bread and veggie stations, and basically tell Simio that I would like to use the work schedule that I just defined for these 2 servers. So I'm going to change the capacity type for these 2 servers from fixed to work schedule, and then I'm going to specify my standard week here. So remember, we defined our day pattern and we stored it in as the standard week. So now when I specify my work schedule in standard week here for the 2 servers, my 2 servers will use my work schedule. So now when I run the model, I expect to see fewer than 40 people during lunch rush and dinner rush in my system, because at those operating hours I'm going to have more workers basically 2 workers at bread and veggies, which were my bottlenecks uh, in the original configuration. So now again, as you can see, I don't see that huge, that long line for the bread station anymore during lunch rush. However, during lunch rush and dinner rush, well, it turns out that our cashier becomes our new bottleneck after we increase the capacity of the other 2 servers. So as you can see, we can change the number of workers and resources in our model using work schedules. And we're going to do more experiments with the model that we just created using rate table and work schedules in the assignments. So the last topic that we're going to cover in this lab is using arrival tables to simulate a particular arrival process, a particular scenario of arrivals. So here I have an Excel sheet that contains actual arrival times of my entities. So for example, this value right here tells me that my first entity arrives at 0.07 hours. My second entity arrives at 0.09 hours, or 5.5 minutes roughly, and so on. So I have the actual arrival times for my entities, and now I would like to simulate the behavior of my system uh, for this particular scenario of arrival process. So I'm going to go to my Data tab and Tables, and what I need is a new data table that I'm going to call Arrivals. And I need a column in my data table, which is a real property. And I'm going to name it, or give it the exact same name that I have here for my column in my spreadsheet, arrival time. So, arrival time. So now what I'm going to do is to import the data from my Excel sheet. So I bind my table to an Excel sheet, and I locate the Excel sheet, arrival times, open, and I can go ahead and say OK. And now as you can see, my table is bound to my Excel file. Now I will go to Binding Options, Manual, and then Import. So now I have imported actual arrival data for 1 day with 573 entities arriving. And I can now go back to my facility view and tell my source object to create entities based on my arrival table. So I'm just going to change my arrival mode property to arrival table, and as Simio requires, you will need to specify the name of the table, which will be my arrivals table, and specifically I want the arrival time column. So now when I hit run, my source object will create entities exactly specified in my arrival table. So this feature is particularly helpful when you have an appointment system where you know when different customers or patients, in the case of a medical clinic or a doctor's office or a dentist's office, are going to arrive. So there are also 2 other features that you can use. You can add arrival time deviations to your actual arrival times. So, for example, I can use a random dot uniform between negative 0.05 and positive 0.05, which basically tells Simio that my arrivals can happen about 3 minutes earlier, anywhere between 3 minutes earlier to 3 minutes later than the time specified in my arrival table. Of course, you can also set the property for the arrival no-show probabilities, but of course it doesn't really make sense in the case of a restaurant that we're modeling in this lab. But I think you get the idea of how the two properties, deviation and the no-show probability, can be used when you're modeling an appointment system.